In a previous video, I demonstrated how to deploy a model immediately after training it using the estimator method. However, there are instances when you might want to deploy a model you've trained previously and stored in a location like an S3 bucket. This video covers exactly that. So today, I will show you how to deploy a model artifact stored in an S3 bucket using AWS SageMaker. If that sounds like something you are interested in, then let's get started. To deploy a model artifact stored in S3 bucket using AWS SageMaker, we will follow these 4 simple steps. First, we import the necessary libraries. Second, we instantiate the model object. Third, we deploy the model, and finally we test the deployed model endpoint. So let's get started with the step 1, importing the necessary libraries. Here are the libraries we will need. The SageMaker libraries will be used for the deployment. Pandas and NumPy will be used for data manipulations, and Matplotlib will be used for data visualization. So let's run the code. Takes a while, so we'll just hang in there for it to finish. The libraries are now imported, so we'll move on to step 2, instantiating the model object. So here is the code to instantiate the model object. The role enables the SageMaker instance to have necessary permission to S3 bucket, whereas the session allows the SageMaker to track the SageMaker activities. Here, we instantiated a Tensorflow model object called tf_model by supplying these parameters to the Tensorflow model class. Model data specifies the S3 bucket URI of the model artifact we want to deploy. In case you are wondering how to get the model URI for a model deployed in an S3 bucket, let me show you that quickly. So you navigate to your S3 bucket like we have here. Better still, let me open it in a different tab. And you see all these buckets. You have to choose the right bucket. So for me, it is this one. And I know that this is the model. The very last one is the model I deployed. So I click on it. Then you click on the model itself. This is it. And then you copy the URI. So this is exactly how I arrived at this. The framework version is set to 2.10 because that was the version of the SageMaker TensorFlow framework I used when training the model. It is important to specify the same framework version used for training so that the correct version of TensorFlow is used when the model is served. The entry point points to the inference script that we want to deploy. Recall that this inference script is what enables SageMaker know how to serve the deployed model to clients making requests. Of course, I've already written that inference script here, and this is it. So we're going to go ahead and run this code so that we can instantiate the TensorFlow model object. Next, we will deploy the model using the TensorFlow model object we created in step 2, and here is the code to do that. The model deployment is accomplished by calling the .deploy method on the TensorFlow object. The 2 parameters we supply to this method, .deploy method, is the initial instance count, which we set to 1, and then the instance type, which is the instance where we want to deploy this model to. We set it as MLP2/large. Now we'll go ahead to run this code and deploy this model. Keep in mind that it takes few minutes for this deployment to be complete, so you have to be patient and wait for it. The deployment is now complete as indicated by this exclamation sign here. And to further verify that, you can click here and go to the endpoints. On the inference, you click on the endpoints, and then you will search for this particular endpoint. There has to be one saying in service. Okay, good. So you can see that is now in service, and when you click on this endpoint, you can also check out the CloudWatch logs just to see, all the reports regarding the deployment, and you see it here. And all this ping successful 200 always is an indication that the deployment is successful. So in case you're trying to deploy yours and you get into you run into an error, it's not successfully deploying, you can come into this CloudWatch log and read through and see what you're probably missing. Okay, so let's head back to step 4, testing the deployed model endpoint. To test the model endpoint, we will load the test data using the following code. The test data is located in the data folder. So you can see the test X contains the test image and test Y contains the corresponding labels. Keep in mind, the model we just deployed classifies satellite images into one of 9 classes. Also, looking at this code, you can see that the test data and the label are all in Parquet. So what I'm just doing here is converting the Parquet input data to NumPy and also the labels to NumPy, because that is what the model requires. I'll go ahead to run this code. Next, we need to write a code to visualize the predicted images, and here is the code. Now let's run the code. Finally, we will write the code that passes the test data to our deployed model endpoint, and here is the code. We pass the test data to the deployed model endpoint using predictor.predict method. If you look closely, you see that we further pre-processed our input data so that the data can conform into the shape that the deployed model endpoint expects, which is why we have this bashed underscore image underscore list. So let's go ahead and run this code to get our predictions. So for this first image, you can see that the predicted class is 7 and the actual class is 7, so the prediction is correct. But I'm sure there will be some that will be off, like this one, the third image, the predicted class is 6 but the actual class is 2. So you can see that when we passed our input data into the deployed model endpoint, we actually got a predicted image. So with this, we come to the end of this demo. I will go ahead now to delete the model endpoint that I created. So I'll go ahead to delete it here. Please delete yours as well. If you followed along, you can do so through the UI like I just did. At the same time, you can also do so by using code. So I hope you found this tutorial helpful. Thank you for watching, and I look forward to seeing you in the next one. Don't forget to like and subscribe to this channel for more insightful tutorials like this. Bye.